Good day, everyone, and welcome back to Batangas State University, the National Engineering University celebration of World Engineering Day for Sustainable Development. This is day 2 of the WED 2023 celebration brought to you by the Center for Innovation in Engineering Education. The global theme of World Engineering Day for Sustainable Development 2023 is Engineering Innovation for a More Resilient World. While here at BatStateU, the NEU, we're celebrating with the local theme Leadership in Collaborative Innovations for a Stronger Nation. We also have a special message from Engineer Federico Fred A. Monsada, President of the Philippine Technological Council and co-chair of PTC Accreditation and Certification Board for Engineering and Technology. He is also a former chairman of the ASEAN Federation of Engineering Organizations, or AFEO. The Philippine Technological Council, or PTC, is an umbrella organization of professional engineering organizations in the Philippines. It is the country representative to the World Federation of Engineering Organizations, an international organization that promotes the practice of engineering for the betterment of humanity and sustainable development. The PTC is responsible for representing the Philippines in the WIFEO and ensuring that the country's interests are well represented in the organization. It is also the sole organization recognized by the Commission on Higher Education, or CHED, and the body of engineering professionals in the country to be the applicant signatory and representative of the Philippine jurisdiction to the Washington Accord. Let's all welcome Engineer Federico Fred Monsada.
Good day to all of you, ladies and gentlemen, and happy World Engineering Day 2023 to all of you. On behalf of the Philippine Technological Council, its member organizations, all of us, I would like to thank Batangas State University for kindly inviting us to be part of this, your celebration of the World Engineering Day. The World Engineering Day was established in 2019 by UNESCO upon the representation of World Federation of Engineering Organization, to which PTC is a national member representing the Philippines, with the objective of recognizing the contribution of engineering as well as of engineering professionals to the sustainable development of many communities and of the whole world today. As you are very aware of. The world has become increasingly volatile, uncertain, complex, and more often very ambiguous. And your celebration of the World Engineering Day is a testament of your commitment to the quality of engineering education, to the quality of engineering practice, and to sustainable development, especially by those whom you have nurtured, the engineering graduates from your institution, who eventually find themselves working, find their presence in many parts of the Philippines and many parts of the globe, such as in the Middle East. It is in this context, ladies and gentlemen, that I really appreciate your adoption of the theme leadership in collaborative innovation for a stronger nation. I would say, I would ask for a stronger, resilient world for all. Collaborative innovation, I believe, is a culture founded on the respect for diversity of opinions, diversity of wisdom, diversity of knowledge, diversity of practices, and yet respecting each other's, eventually getting together for a shared goal or goals, and that is collaboration. On the other hand, innovation is change in mindset, I would say. Innovation means continually using your knowledge, your skills, and even your beliefs in creating new things, in critically thinking on what new things to create, on what improvements to do, so that the process, the product, or the way we do things eventually will ensure that what we have developed serve a greater purpose. What product we have produced, what process we have produced, what practices we have developed serve a greater purpose, which is what we believe is a shared goal among those participating, working together, collaborating, and that is collaborative innovation. So therefore, if you look at collaboration of getting together in spite of the diversity toward, you know, getting together towards a shared goal and doing something together, doing something to improve, to create is by itself. And when that happens by itself, it becomes a culture, collaborative innovation. So for me, I would like to see engineering educational institution like yours, like Batangas State University, and even professional organizations, including communities where problems are, to develop that kind of culture of working together, innovating things, some common purposes or some common goals. So, what is the role of the educational institution, therefore, in making sure that thing, this culture of collaborative innovation will eventually be a thing that thrives within communities? It's me. Educational institution has a lot of things that you can do, has a lot of things that you can, in fact, influence future engineering professionals, especially as you are the National Engineering University. It is just fortunate the International Engineering Alliance, working together with the World Federation of Engineering Organization under the support of UNESCO, has developed the graduate attributes and competence profile exemplars that can be used not only by the institution, by the educational institution, but also even by the professional organization like PTC as an exemplar or as exemplars of what we expect graduates to be and future professionals to be. What we expect students to be able to possess and be able to demonstrate, and what we expect professionals who are already in practice to aim for and eventually be like in the future. These graduate attributes and professional competence have been incorporated in not only by the Commission on Higher Education, but also has been adopted by PDC being a member of the International Engineering Alliance as part of its consideration, as part of its key reference or exemplars in defining what we would like our engineering professionals to be in the future. So what do these graduate attributes and professional competence profile or exemplar have to do with collaborative innovation? I believe that there are many components, if not all of the components of the graduate attributes, when adapted, will ensure that collaborative innovation can be a reality, can always be a reality as it is in many parts of the advanced countries of the world. One of the key issues, one of the key attributes rather, that I can emphasize is the ability of graduates, of new graduates, to understand contemporary issues, social issues, and all other considerations that may eventually have some influence on the solution to engineering problems that are facing humanity. The ability to communicate this shared goals with all parties involved is one such attribute that I also would like to see and emphasize when we finally adopt these graduate attributes in our engineering education system. Many others, working in teams, working together as teams and working as a member. And of course, the most important one that I've seen in this graduate exemplar is putting the society, the welfare of society, understanding society in the context of engineering solutions or vice versa, and ensuring that indeed we are designing solutions, we are developing solutions. We engineering professionals are developing solutions in the context of what the community needs, what the community needs. There's synergies among the communities that are transcended by the problems. So, ladies and gentlemen, such graduate attributes and professional competence exemplars being nurtured by IEA and has been adopted by BTC as well in all its standards, in all its criteria that we use in accreditation of engineering program in assessing the competencies of our professionals. We believe that these are very important for us to be able to ensure that at some future date when this graduates in their practice, they will have the culture that is needed for us to effectively, undertake and even lead collaborative innovation in this country to ensure that any and all solutions to what we are doing are indeed sustainable, as what this celebration, the word engineering day, really means. For all of us to get together for some shared goals that benefit not only a few, but as many of us. As we develop these solutions, we sincerely believe that we have achieved our contribution as educational institution, as professional organizations. If only we're able to espouse this culture of collaborative innovation in our country. With that, I would like to thank Batangas State University again for this honor to be part of your celebration of the World Engineering Day. Thank you very much.
Thank you very much, Engineer Fred, for co-celebrating WED 2023 with us. As we delve deeper into the concept of education and sustainability, it's important to understand the role of engineering in shaping our future. Today, we have with us Dr. Christian Delia, an assistant professor in mechanical engineering at the James Watt School of Engineering, University of Glasgow, UK, and the president of the Philippine Society for Engineering Education, or PSEE. Dr. Delia will be sharing his insights on how we can promote sustainability through the integration of engineering simulation in the engineering curriculum. Dr. Delia's extensive experience in the field of engineering and education makes him a valuable speaker in understanding the role of engineers in shaping a sustainable future. Without further ado, I'd like to welcome Dr. Christian Delia to our session on Educator Insights.
Hello, everybody. I'm Christian Dalla. I'm currently an assistant professor at the James Watt School of Engineering, University of Glasgow, UK. I'm currently based in Singapore in our mechanical engineering program with the Singapore Institute of Technology. I'm also currently the interim president of the Philippine Society for Engineering Education. Welcome to my talk on promoting sustainability through integration of engineering simulation in the engineering curriculum. before we discuss integrating engineering simulation in the engineering curriculum, let's discuss the 2030 Agenda for Sustainable Development. The 2030 Agenda for Sustainable Development is a global plan of action adopted by the United Nations General Assembly in 2015. At the heart of the UN, the 2030 Agenda for Sustainable Development are the 17 Sustainable Development Goals, a set of interconnected goals and targets aimed at addressing the world's most pressing economic, social, and environmental challenges. To summarize, there are three elements of sustainability: the environmental sustainability, which involves reducing pollution and waste, conserving biodiversity, and minimizing the impact of human activity on the natural world. Social sustainability involves creating an equitable and just society where everyone has access to basic needs such as food, water, shelter, healthcare, education, and opportunities to fulfill their potential. The third is the economic sustainability, which involves using resources efficiently, creating jobs and income opportunities, promoting innovation, and ensuring economic stability and resilience. Now, allow us to define engineering simulation. Engineering simulation is the use of computer-based mathematical models and algorithms to simulate the behavior of physical systems or processes. This involves creating a virtual representation of a real-world system or a process to predict its behavior under different conditions. Engineering simulation is a powerful tool that can provide valuable insights and help engineers and scientists make better decisions in the design, development, and operation of products, processes, and systems. Engineering simulation has been supporting sustainability, such as the design of green building, environmental design, water management, air quality management, energy efficiency, and product development. So, how can engineering simulation contribute to the UN Sustainable Development Goals? Well, there are many ways. So for good health and well-being, which is SDG 3, the use of simulation can optimize the design of medical devices and drug delivery systems, leading to improved health outcomes and reduced costs. For SDG 5, which is gender equality, simulation competency help increase access to education and job opportunities and engineering and related fields, promoting gender equality and diversity in the workplace. SDG 6, clean water and sanitation. Engineering simulation can help optimize the water treatment processes, reducing the amount of water required and the amount of pollutants released into the environment. SDG 7, affordable and clean energy. Engineering simulation can help optimize the design and operation of renewable energy systems such as wind turbines, solar panels, leading to increased efficiency and lower cost, contributing to the goal of providing affordable and clean energy to all. SDG 9, which is industry, innovation, and infrastructure. The use of engineering simulation can help optimize manufacturing processes, reduce waste, and improve supply chain operations, leading to more sustainable and efficient industry practice. SDG 11, which is sustainable cities and communities. Engineering simulation can help design and optimize urban infrastructure systems such as transportation networks and water distribution systems for more sustainable and efficient cities. SDG 12, responsible consumption and production. The use of simulation can help optimize material and energy flows in manufacturing processes and thereby reducing waste. SDG 13, climate action. Engineering simulation can help identify and mitigate environmental risks associated with industrial processes, infrastructure development, and natural disasters. It can also help optimize renewable energy systems, reducing greenhouse gas emissions, and promoting low-carbon economy. SDG 14, or Life Below Water. Engineering simulation can help model and mitigate the impact of human activities on marine ecosystems, such as oil spills and plastic pollution. SDG 15, Life on Land. Engineering simulation can help optimize resource use in agriculture and forestry, leading to more sustainable land use practices. SDG 17, Partnerships for Goals. Engineering simulation can help facilitate collaboration among various stakeholders such as industry, academia, and government to address complex sustainability challenges and promote sustainable development. As presented previously, the engineering simulation has a lot of practical applications in supporting sustainability. Now, engineering simulation has been quietly addressing many of the underlying issues on sustainability. Simulation has influenced the conceptual design stage with the biggest impact on the final product's carbon footprint, such as in renewable energy, wind, wave, tidal, solar, smart energy, energy-efficient buildings and built environment landscape, transportation vehicles, acoustic pollution abatement in urban and transport environments, product waste reduction at conceptual ideation and in manufacturing processes, legislative environmental compliance at the conceptual stage. So in this presentation, I will be promoting sustainability. How can we promote sustainability in the engineering education by integrating engineering simulation in the engineering curriculum? For the engineering simulation, I will be discussing the finite element analysis and the computational fluid dynamics, which can be integrated in the engineering curriculum, specifically in mechanical engineering, which can be applied in other engineering disciplines such as civil engineering and chemical engineering. Finite elements has always been used to simulate mechanical systems to analyze its performance and efficiency, as well as the safety of the products and the processes, which leads to lesser waste as well as faster development time. For computational fluid dynamics, these are computational methods used to solve problems related to fluids. CFD enables scientists and engineers to perform numerical experiments in a virtual flow laboratory, thereby reducing the waste of developing physical prototypes. So why do we use CFD? Numerical simulations of fluid flow will enable architects to design comfortable and safe living environments, designers of vehicles to improve the aerodynamics characteristics, chemical engineers to maximize the yield from their equipment, petroleum engineers to devise optimal oil recovery strategies, surgeons to cure arterial designs, surgeons to cure arterial diseases, meteorologists to forecast the weather and warn of natural disasters, safety experts to reduce health risks from radiation and other hazards, and military organizations to develop weapons and estimate the damage. Computational fluid dynamics can also help improve the design and the performance of renewable energy equipment. Computational fluid dynamics can also be used in devising sustainable drying methodologies. Computational fluid dynamics can also help us exploit the use of the natural ventilation in developing a more greener environment. Computational fluid dynamics can also be used for materials and chemical processing, such as in chemical sprays, heat exchangers, dryers, mixing, metal processing, and separation and filtration. This allows us to be able to visualize the process without developing any physical prototypes that can be wasted after the test has been done. Computational fluid dynamics has been studied to be able to look at various urban physics problems to solve grand society challenges such as in climate, energy, health, security, transport, and aging. I would like now to share how we are able to integrate the finite element and computational fluid dynamics in the engineering curriculum of the Singapore Institute of Technology and University of Glasgow Mechanical Engineering program in Singapore. So, aside from being able to promote sustainability through the use of engineering simulation, there are also many advantages on integrating engineering simulation in the engineering curriculum. Engineering modeling and simulation, such as finite element analysis and computational fluid dynamics, have become common in modern engineering workplace. Modeling and simulation have been integrated in teaching mechanical and civil engineering courses to improve learning, such as basic mechanics. Modeling and simulation have been integrated in engineering courses for students to gradually develop their skills and competence in modeling and simulation and prepare them for the workplace. There are many importance of integrating simulation in the mechanical engineering curriculum. So engineering simulation can be used as visualization tool to enhance learning of mechanical engineering modules or courses. For example, in mechanics of solids, the use of FE models can help the students visualize the stress and deformation contours within the loaded structural members. Engineering simulation can be used as virtual experiment tools where students can conduct experiments in a safe environment. Further, the use of engineering simulation can help improve the problem-solving skills of engineering students, since visual learning methods can open new ways to solve engineering problems and provide alternative ways of thinking about science and engineering. The use of engineering simulation in teaching can develop industry-relevant skills for students because the early exposure of students on modeling and simulation practices can help them gradually develop their modeling and simulation skills and be prepared or be ready for the workplace. Professor Rajesh Bhaskaran from the Sibley School of Mechanical and Aerospace Engineering in Cornell University that the new paradigm in engineering education uses two disruptive technologies. One is simulation and the other being online learning. Now, this was presented earlier before the COVID pandemic. Due to the COVID pandemic, the online learning has been accelerated. Now, in Cornell University, they were able to successfully integrate simulation in their engineering program. They were able to integrate finite element analysis, or FEA, and computational fluid dynamics in the undergraduate and graduate mechanical engineering program. Among them are in the mechanical structures, heat transfer, mechanical lab, thermodynamics, fluid dynamics, wind energy, biofluid mechanics, advanced heat transfer, biofluids, as well as the mechanics of bones. Currently, we are integrating simulation in the Singapore Institute of Technology and University of Glasgow Mechanical Engineering program, and we would like to share the work that we are currently doing. At the Singapore Institute of Technology, University of Glasgow Mechanical Engineering, we have three approaches to integrate simulation in our curriculum. One is through the learning of fundamental concepts through integration in the engineering or undergraduate curriculum or undergraduate courses or modules. Here we integrate finite elements in the engineering mechanics. We integrate finite elements in the mechanics of solids, dynamics, and heat transfer, as well as in the additive manufacturing, while we also integrate computational fluid dynamics in the fluid mechanics course. So there are opportunities for students to also apply what they have learned through non-placement learning activities, such as in their mechanical design, in their capstone project, as well as in the overseas immersion program, where the student has to spend some time working on engineering projects at the University of Glasgow in the UK. The students will also have opportunities to apply their knowledge in engineering simulation during their internship, which we call the Integrated Work Study Program by the Singapore Institute of Technology. Some of the companies where the students were able to work using their engineering simulation skills are Rolls-Royce, CSIM Systems, Experimental Power Grid Center, Pingshong International, Genesis MedTech International, and Ning Research. The students have to learn the finite element modeling and analysis process, which involves pre-processing, solving, and post-processing. The students will be able to learn developing finite element models in their engineering mechanics. Workshops on the use of simulation software such as ANSYS has been conducted to train the students to use the tools to perform FE and CFD analyses. Through the use of the FE models, the student can visualize the deformation and stress contours within the structural member. The students will also be able to develop FE models and compare their simulation results with actual tensile test results. This will provide students the confidence in developing their finite element models because they are able to validate their results with experimental data. So similarly, for strain measurement in mechanics of solids, the students develop finite element models and compare their finite element results with the physical strain measurement results. This further provides the students the confidence in developing finite element models. The students will also be able to develop FE models and compare their finite element results with the results of the analytical solutions. Through this practice, the students will be able to understand the best practices in developing FE models, which further provides the students the confidence in developing finite element models. The students will be able to apply their knowledge on finite element on thermodynamics and heat transfer problem. So a simulation laboratory is included in the thermodynamics and heat transfer module, where students will apply heat transfer concepts learned to a software simulation assignment. The assignment starts with a simple 2D plate analysis where students use this simple problem to appreciate the difference between analytical and numerical solutions. The assignment ends with a heatsink design task where the students are given a scenario to optimize and justify the heatsink design. After learning the finite element analysis, the students will learn the computational fluid dynamics. So first, we have a workshop where the students will be able to learn the CFD analysis process. So similarly with the training on finite elements, the students will be able to understand the three major processes or the three major steps in developing a computational fluid dynamics model. The first is the pre-processing, solving, and then post-processing. The students now will be able to apply their computational fluid mechanics skills in solving simple problems in fluid mechanics. Now, for the non-placement learning activities, the learners will be able to apply their simulation skills in various activities such as mechanical design, in design projects during their overseas immersion program, and in capstone projects. So the students here will be able to learn that through the use of simulation, they will be able to further improve their design. They will be able to test and evaluate their virtual prototype, and they will be able to further improve the design through iteration. Students are able to apply their knowledge and skills in simulation through project-based modules such as mechanical design and the overseas immersion program. So here are some examples of the projects of the students using computational fluid dynamics in their mechanical design. So students have been asked to design and develop a 3-in-1 mask cleaning device. They were successful in improving the performance of their design through the use of simulation. Similarly, to be able to come up with a design to improve the mask wearing experience, the engineering students were also able to use the computational fluid dynamics to improve the performance of their design. So after the learners being able to learn finite element and computational fluid dynamics in various courses or modules, as well as apply some of the skills they learn in non-placement activities, the students will be able to have the opportunity to apply what they have learned during their internship, or what we call the integrated work study program. So for the work integrated learning, the mechanical engineering students have been assigned for internships that require simulation. So this provides opportunities to students to further improve their knowledge and skills in simulation. To summarize, at the SIT University of Glasgow Mechanical Engineering program, there are 3 ways where students will be able to learn and apply engineering simulation. One is through the learning of the fundamental engineering courses. The second is through non-placement learning activities. And the third one through work integrated learning. Engineering simulation is evolving. And with that, we see digital twin to be the next wave in simulation technology. It's defined as the seamless integration in Industry 4.0 technologies to be able to see what's going on with the physical twin. And we see that simulation is an integral part in the digital twin. Digital twin has been seen to grow to $48.2 billion by 2026. Digital twin can be further used to be able to monitor an urban environment. We also see mechanical engineering to be evolving. So recently we have the Texas State University to have presented their Mechanical Engineering 4.0. And with this, we see digital twin and simulation to be an integral part of their Mechanical 4.0 curriculum. So what are the motivations for developing simulation competitiveness in the Philippines? One is employment and job creation, because the competency in engineering simulation can result to better wages. Number 2 is the quality and productivity, making the products in the Philippines at par with international standards. Knowledge and skills development, which means that having skills in simulation can help Filipino engineering professionals grow their career. Fourth, innovation and product development, where Filipino innovators can transform their idea into practical reality. 5, internationalization, where Filipino innovators can design the product in a way that it may be readily consumed across multiple countries. As we can see, the information technology and business engineering process management, this sector has generated 166 billion in 2015, has been forecasted before to have increased to $250 billion in 2022. This was a report by the DTI, the Department of Trade and Industry in the Philippines in 2018. Some of the high-value services for the IT-BPM are the engineering services outsourcing, data analytics, performance management, and legal process outsourcing. So far, India and the Philippines are leading the international IT-BPM market. It has been said that the engineering services outsourcing makes up to 55% of the global IT-BPM market, which currently the Philippines hasn't exploited so far. In fact, at the moment, the focus is more on the call center outsourcing. However, in the Philippines, we still need to further improve our engineering competency to be able to increase our share in the global engineering services outsourcing market. As mentioned by DTI, for the short term, to be able to develop our talent pool, we need to establish training centers collaborating with global multinational companies and upskilling engineering services outsourcing companies. We also need to upgrade our curriculum in the Philippines, which includes lower-end skill sets as mandatory subjects at university and technical institutes, and also emerging technologies and sectors in the curriculum at university level. For the mid to long-term development, we need to improve the quality of education in the country. We need to focus more on technical and engineering skills and improve the quality of math and science education. We need to develop innovation centers as well as institute partnerships for R&D and recruitment. So this is the suggested 4-year competency development program. For the first 2 years, we can develop the competency by developing training modules, certifications, and pilot them to basic trainings and certify trainers to be able to train. For the 3rd year, we can use as a project-based application where we can contribute to manpower. We can use what we have developed during the first 2 years to be able to apply to local market or local industry. And finally, in the 4th year, we can further develop local centers for computational mechanics or engineering simulations, developing product designs or developing products as well as developing local products for the global market. That is all for my talk. Maraming salamat po.
Thank you, Dr. Delia, for that enlightening talk on promoting sustainability through the integration of engineering simulation in the engineering curriculum. Your insights on the importance of innovation and collaboration in driving sustainable engineering solutions are truly valuable. I'm sure our audience has gained valuable insights from your presentation. Now that we have a deeper understanding on how engineering plays a crucial role in sustainability, let's shift our focus to another important aspect, building resilient communities. Our next speaker, Professor Dexter Eslo, the Vice President for Social Development at Xavier University, Cagayan de Oro, will be sharing his expertise on how we can build resilient communities through safer schools. Professor Lo's work in education and community development makes him a valuable speaker on the topic. So without further ado, let's welcome Professor Dexter Eslo.
Good day. Thank you for giving us time and opportunity to share our work on safe schools and resilient communities. My presentation will be in 3 parts. Let's talk about safe schools, let's talk about risk and resilience, and I will share some case studies. Let's start with looking at this picture. We see that this is a school being constructed, and oftentimes we think that the ones involved in the construction or the project are usually just the architects, the engineers, and probably the contractor. But what about the user of the school? More so, if we look at this picture when it is done, there's a lot of external stakeholders that you can see around there. For example, the houses, the residences around the school. So I think we need to think about systems when we talk about the safety of our schools and how does it affect the resilience of communities. In reality, also, we see, particularly in the Philippines, this picture, school children carrying their chairs instead because the school compound is flooded. We also see pictures like this when the roof are blown off, and yet children continue to learn, but that might be not so conducive for learning. We also see this one, I think this is due to earthquake and the ceiling fell off, and it is quite dangerous. And of course, in the Philippines, we also realize and we also see and probably even experience that our school campuses are being used as temporary shelter or evacuation shelter during or after a disaster. So what is really a safe school? And we can define safe schools in many different ways depending on our experience and priorities. But if I were there, we could probably do some sharing as to what you think about a safe school. Many would probably say that it should be about the facilities, where we should be able to follow the building code when we construct the building, and also the safety of the site, that it's not landslide prone or flood prone, and other standards other than building could be electrical, fire code, etc. But some would probably think that it is about the school disaster management, that if there are disasters, God forbid, then there is a committee that is actually in charge. There is a plan on what to do, and there are provisions as to how to respond. But because it is also school, then we might also think that it is a place where children and even adults can also learn about risk reduction. So it should be integrated in the curriculum, etc. And this could actually cross over or intersect. For example, when we talk about facilities and we need to have the management in terms of disaster, then probably we need to maintain the facilities so that our contingency plans, our response provisions, whether, for example, that's a fire extinguisher, would actually work when there is really an eventuality. Other than that, if we are talking about education and when our children see that our schools are being repaired or retrofitted, then they could actually do that or replicate it in the household level. And that is also education. So actually, these ideas are not foreign, and this is not something we think about on our own. There's actually UNDRR, it's now called UNDRR, 3 pillars for comprehensive safety schools. And indeed, it is about safe learning facility, it is about school disaster management, and risk reduction resilience education. And a heart of it is actually multi-hazard risk assessment, which I will talk about in a little while. And the Philippines is actually a signatory to this agreement, as dated here in August 2015. So the Philippines is actually part of this global initiative for promoting or implementing safe schools. And some of you might have known about the DRR pillars or DRRM pillars, doing prevention, mitigation, response, preparedness, and recovery, for example. So this is not something that we should recreate, because we only find the intersection. For example, if we do safe learning facility, then that is actually to already do prevention and mitigation, etc. And there's actually a newer document published by the Global Alliance for School Safety and Resilience. So it's basically the same, it's just being enhanced for 2022 to 2030. And basically, it should be participatory, risk informed. So again, I'll talk about risk, and the objective or the goal is to protect the learners, the educators, and the staff. It is also to plan for education and protection continuity so that there is less disruption and our students are able to learn, and promote knowledge and skills of learners and duty bearers like the school administrators to contribute to risk reduction and resilience. So very quickly, I'll share to you the risk concept because I'll talk about risk. So risk is basically a probability of a disaster to happen or something that is undesirable that could happen. It's just a probability, and this probability is made possible if these 3 elements are present. Foremost, there is a hazard, like probably a natural trigger like earthquake, storm, or even a virus for that matter. And then it so happened that there is an exposed element, whether that's people, buildings, properties, that are along the way of the hazard or that could get hit by the hazard. Eventually, there is actually a parameter called vulnerability or our weaknesses when such hazard, for example, will hit a certain population or certain property and it is not built well, it is not engineered, then the probability of failure could really happen. So this is the science behind disaster risk assessment, when we are able to say there is really a possibility that a disaster could happen. When, for example, at this place, for example, when there is hazard, and there are exposed elements, but if they have the capacity or the capability was already built, and therefore the risk couldn't be as much, or there is even negligible risk for that matter. Of course, we recognize that hazards could be increasing. For example, climate change aggravates our rainfall patterns. So the risk could actually be bigger now. And we also recognize that population is also increasing. And therefore, that overlap there, the risk is actually also increasing. However, technically, this exposed element could go somewhere far, no, from the harm's way, although that is technically possible, but not necessarily always easy. But what is, I think, important to recognize is that the vulnerability could actually be reduced when we are able to teach people what to do engineering measures, for example, so that our buildings could at least withstand strong shaking, either from wind or earthquake, etc. And in that way, the risk that we are talking about, or the probability of having a disaster, could actually also decrease. Now, there are a lot of formulas out there as to how to analyze risk, but what I will show you in the case studies that I will share is through maps. I like maps because it immediately situates where we are, and you can probably imagine what your situation is, no, or the probability or scenario that could happen. So we did this study about 8 to 9 schools. These are central schools in Cagayan de Oro, because these are central schools. These are the most populated schools. And we used the risk framework of hazard, exposure, and vulnerability. And there you will see the many parameters that we used. And let me just focus very quickly on the vulnerability. In this study, we actually, of course, considered structural vulnerability, like when the structure was built, the irregularity, because this would have different seismic response, the building height, etc. We also considered the non-structural vulnerability because some of the building elements, although non-structural, may actually fall off and could hurt people. And as well as the functional vulnerability, whether, for example, the exit doors or the safety of doors will open outside in case of emergency, etc. And let me, of course, this is just some formula to follow, but as I've promised, let us see that in terms of maps. So here you see, for example, in one school campus, these are the buildings, the hazard is actually the same when the earthquake happens here. There are differences, in terms of the population per building, and these are the vulnerability, structural vulnerability, but also considering functional and non-structural. And this is the result. And we see that indeed there is an interplay whether this building, for example, is the most populated or the most vulnerable, and we can even place threshold values, saying that, oh, these buildings are really at high risk. But what's important is we can go back as to what is the reason, or why is this at risk? Is it because there are too many occupants there, or is it really because structurally or in terms of non-structural components, they are most challenged? We did this for about, as I've said, 9 schools, campuses, and we also simulated in terms of the intensity, in terms of the magnitude of the earthquake, less than 6.5, up to 7, and up to even more than 7. And in summary, we can see that for a very large earthquake, about half of our schools are actually at risk. Although we have to remember that the risk here, in terms of vulnerability, is defined including the non-structural elements and the functional elements. But of course, we cannot stop at the problem. It is important that we find solutions to these problems. And so that's why Xavier University, in partnership with De La Salle University and the University College London, did some studies back in 2016 called the SCOSO project. The aim was to develop multi-hazard, so now not only for earthquake, but for strong winds and floods, for example, risk assessment framework for school infrastructure in the Philippines. And 2 years later, we continued our study and called PRISM H. This is Philippines resilience of schools to multi-hazard. So in this project, for example, we are here to investigate the effectiveness of building retrofit. So it's now more of the solutions that should be introduced, because we have already determined the risk in the former project, and could early warning be also applicable, as well as the social preparedness and the functioning of the school infrastructures and its role in the community, as I've said. And now what we are doing is the UNESCO Chair project in disaster risk reduction and resilience engineering. This will actually create a research network and shared knowledge, which promotes a shift now in approach to just school safety from individual buildings to local and regional school infrastructure, including critical lifelines, for example, the roads that connects our school. As I've said earlier, the school safety and resilience of our community must be connected. It cannot be dichotomized. And so, very quickly, let me define resilience. According to UNDRR, it is the ability of a system or a community exposed to hazards to resist, absorb, accommodate, adapt, but more importantly, to transform. To basically, in engineering terms, it has to be repaired or retrofitted, or maybe even redesigned, so that it will be able to recover timely, from an effect of a hazard in a timely and efficient manner, including the preservation of the functions, the basic functions in particular. So in a graphic form, I think this is a very good way of looking at resilience. When, for example, of course, our building, your school building, for example, will have an initial resilience level. And when it gets hit by an earthquake or strong wind, for example, then it could probably crack, collapse, God forbid, then therefore the resilience actually drop drastically. But if we only do response, for example, just relief operation, and even just making temporary shelters, that will not build our resilience. What we want to do is we can build better, for example, so that our resilience will actually increase, such that if this magnitude again will hit our building, then we will not be our resilience will not dip so low that we can recover even faster. So let me share again some studies that we have done for schools in Cagayan de Oro in particular. So yes, we know that during earthquakes, there are a lot of structures that could get affected. Hospitals, offices, houses. But in this study, we just focus on schools because the children, for example, could be vulnerable sector. And as I've said, school campuses are also being used during and after a disaster. So more so, this is the reason why we make sure that our schools are safe in order to help build the resiliency of our communities. So the framework, the engineering side here is basically we have real earthquake records, so we need to collect them. And then we made structural models of the buildings that we analyzed here, and analyzed using pushover analysis, and able to produce our seismic capacity. And we are able, when we combine the capacity of our building with the demand from actual earthquake records, then we can determine the seismic performance in terms of fragility curves. So basically, what you will see late in a little while, the curves will describe the state of damage of our building. For example, when we say moderate damage, this means that there is cracking in most beams and columns, some yielding in a limited number, and some spalling. So that these are the descriptors. So just one example to to illustrate what we've done. So this is a building with the square floor area, how many rooms, 3 stories, and the occupants there. And so this is the structural model, and this is the result. So for this building, for example, in terms of slight damage, this is the curve. I will explain in a little while in detail. In terms of light damage, moderate damage, and extensive damage. So we see, for example, in terms of moderate damage, we see that in terms of peak ground acceleration, when the peak ground acceleration that will hit in this area would be around 3 meters per second squared, then there is probably about 85% probability that this building will experience moderate damage, no, as described earlier. But if the intensity or the intensity of the shaking is only about 2 meters per second squared, then this building would probably experience about 50% probability of moderate damage, so only 50%. So this is how to use these curves. Incidentally, if we see at the Philippine Earthquake Atlas, the expected peak ground acceleration in the area in Cagayan de Oro is about 2.9 to 3.9 meters per second squared. So in summary, we say that this building could experience around 100%, no, very certain slight damage, but we see earlier what does that mean. Slight damage basically means just hairline cracks in columns, beams, of frames. But then this will experience here light damage about 100%, but for moderate damage, which could be a parameter that we must really look at, it's about 86 to 98%, but there is no collapse, no, expected for this building. What's also nice in this kind of analysis is we can actually, because we've run the pushover curve, we can actually determine at least approximately, you know, the location of the weak points of the building, and if we would want the building to be retrofitted or to improve its performance, then we might want to consider checking or reinforcing these areas there. So in summary, we have actually done for about 8 types of buildings, different configurations. Some are regular in terms of geometry, some are letter U, some are letter Z, and different stories, so that we will see a different different behavior of our school buildings here. And fortunately, in terms of performance, for example, basically only moderate damage, no collapse is expected for these buildings. So this are the kinds of technology and science that could actually help us determine the performance of our buildings, and if they are really weak, for example, then we could actually build the resilience even before the earthquake will happen. So as I've said, moderate damage is described in these terms. For my last slide, I'd like to share this from our paper, which you can actually download and read, called Resilient Communities Through Safer Schools. I'm just comparing, for example, the 2 buildings would have different level of performance, as I have shown earlier, in the 8 buildings. Let's just, for example, focus on the red curves called life safety. For example, for this building, at this intensity of shaking, it would probably experience about 50% probability, and then that's life safety already for this building. While for this building, at the same intensity, it could experience about 90% of life safety already being used up. So basically just 10% left in terms of life safety. But other than able to compare the different behavior of our buildings, let me now bring our focus to the broken curves here. So this is the performance when the building would have been retrofitted, whether they are using steel bracing, concrete jacketing, or fiber reinforced polymers. So for this building, At one, for example, intensity of shaking, instead of performing about 50% of life safety being used up, then it's only about 20% or 25% now being used up. More so for this building, which at the same intensity would actually use up about 90% of its life safety performance, it's only now down up to about 50% for this building. So this really gives us hope. This kind of technology could be used for us to better assess and understand how we can improve the structural performance of our building and therefore build resilience, reduce risk in terms of structural engineering. And in fact, in the parlance of DRR, the fragility curves are now very popular in Europe and United States for the insurance company because they are able to assess better how the structure should be insured in terms of insurance policies because they know better how it will perform in terms of uncertainties that could happen like earthquakes or strong winds. So I end there with my presentation. Thank you very much. I hope you have learned something today. Thank you.
Thank you to both Dr. Christian Delia and Professor Dexter Eslo for their insightful presentations on sustainability and leadership. Your expertise in your respective fields has provided our audience with valuable insights in how we can create a sustainable future for ourselves and future generations. We hope that the knowledge and ideas shared in this session will inspire our audience to take action towards building a more sustainable and resilient future. As we move forward from our Educators Insight session, I want to shift our focus to the importance of student engagement in creating sustainable solutions for the future. Our next segment will highlight some of the incredible work being done by students in the engineering field.
The World Federation of Engineering Organizations is proud to announce the World Engineering Day Hackathon. The World Engineering Day Hackathon will encourage engineering students from around the globe to work in teams towards a global, real-world problem. This competition is a fast-paced simulation of an engineering project. Utilizing their scientific and engineering knowledge, university students will work collaboratively to gain first-hand experience to develop their critical thinking, build new skill sets, push themselves out of their comfort zone, and create lasting relationships. WIFIO has partnered with Engineers Without Borders to identify and present these real-world problems which are directly related to the World Engineering Day theme and will involve solutions that advance some of the United Nations Sustainable Development Goals. Teams must choose one of the proposed challenges and will have 2 weeks to formulate their solution and upload their written submission. A few select entries will be identified as finalists. These finalist entries will be widely promoted and viewed by millions during the World Engineering Day celebrations.
As we heard earlier from Dr. Christian Delia, integrating engineering simulation in the curriculum can play a crucial role in promoting sustainability. By honing the skills of our engineering students, we can create leaders who are equipped to tackle the challenges of global sustainability. Student engagement is an essential aspect of the educational experience, as it allows individuals to develop their skills and interests while contributing to the growth of their academic community. In particular, honing the skills of engineering students can play a critical role in creating leaders in global sustainability. As a champion of student efforts, BatStateU, the NEU, through the CIEE, is dedicated to supporting students in their pursuit of innovative solutions that address real-world challenges. In the succeeding report, we will showcase 3 impressive initiatives led by engineering students. These initiatives demonstrate the valuable role that student engagement and skill development play in advancing global sustainability. Batangas State University, the National Engineering University students collaborated at the CIEE to address the challenges presented in the WED Hackathon. The challenges focused on zero hunger, clean water and sanitation, and good health and well-being. 7 teams from different engineering disciplines participated in the hackathon this year, and each of them addressed a specific SDG. The teams were given a 1-day workshop by the CIEE to assist them in their deliverables and to guide them in addressing the SDG problems.
March 11, 2020. The World Health Organization declared the novel coronavirus a global pandemic. The COVID-19 crisis has caused a catastrophic loss of life on a global scale and imposes unprecedented threats to public health.
Not only does the pandemic present challenges for disease control, but it also has long-term and far-reaching effects on the environment, and its impacts are far from over.
Access to safe water is one of the basic human needs for health and well-being. Water risk in terms of scarcity, extremity, and pollution arise as an outcome of poor management, over-extraction of groundwater, and contamination of fresh water.
Around 5,500 metric tons of face masks were discarded in 2020, equivalent to 7% of the total mass of plastic debris in the ocean. Such plastic waste can last up to 450 days, in which one surgical mask releases up to 173,000 microfibers per day. Moreover, single-use surgical face masks act as dye carriers, accounting for 20% of all global water pollution. Textile dyeing implies risk to both humanity and the environment. Its polarity makes it difficult to be eliminated using conventional water treatment methods and eventually end up in drinking water. Toxic dyes and face mask pollution. How can we address these environmental concerns? Will you believe me if I tell you that this waste can be transformed to a remarkable technology through innovation and incorporation of chemical engineering principles? If you're curious, stay with us to find out.
Disposable surgical masks are composed of complex carbon structures, mainly polypropylene, polyethylene, and polyurethane, allowing it to be a promising candidate for the production of a novel carbon quantum dot.
Through chemical carbonization, we upcycle discarded face masks into valuable fluorescent nanomaterial. Carbon quantum dots are nanoparticles made of carbon atoms that exhibit strong light and have a broad absorption spectrum. It possesses unique characteristics such as low toxicity, tunable fluorescence, and good water solubility, while its vast surface area caters the interaction with dye molecules in order to promote photocatalytic activity. This was intended to address the sixth SDG, which is the clean water and sanitation, striving in delivering water of higher quality in a more cost-effective, affordable, equitable, and sustainable way.
Utilization of this noble wastewater treatment to restore marine resources and conserve aquatic life outperforms conventional carbon dots, owing to its facile synthesis and the use of non-biodegradable carbon source, upholding both SDG 14 and 12.
Applying engineering principles, the absorption and emission of the synthesized carbon quantum dots were optimized using Minitab and Design Expert. 10 ml of our carbon quantum dots can degrade 50 ml of wastewater at a cost of only $3, which is 98% cheaper than its commercial cost.
This shows that our solution is desirable for water remediation of type pollutants, aiding the drawbacks of other technologies by providing a more economic and efficient method.
The project resulted in overall cost of $370. To improve the current study, we seek to establish partnerships with government and private institutions.
With sufficient fundings and support, our innovated carbon quantum dots can be further improved as it offers a wide variety of applications, including heavy metal and biological sensing, gene and drug delivery, and photodynamic therapy.
Water, as the cradle of life, is a resource that we must conserve. Equipped with chemical engineering principles, we, Team Musketeers from the National Engineering University of the Philippines, stand to be the embodiment of resilience and treat these challenges as virtues.
As soldiers of the environment,
Armored with our innovation,
We take action and traverse the path
towards a cleaner and brighter future.
5 teams from electronics engineering, computer engineering, and chemical engineering joined the Engineering Innovation Competition, or EIC, in Singapore last September 2022. The students underwent a workshop at the CIEE to further educate them and help them prepare for the competition. Team AI Aquaponics 360 was announced as the overall champion in the university category. The remaining teams received merit awards and recognition for participation. The NEU Red Spartans from the Mechanical Engineering, Electronics Engineering, Electrical Engineering, Automotive Engineering, and Industrial Technology majors joined the Shell Eco Marathon competition last January, with their prototype car, Sparta, under the combustion engine category. The competition aimed to develop an engine or a vehicle that can function, given the ample amount of fuel while addressing the problem of fuel efficiency. The team has surpassed Phase 1 and is currently working on Phase 2, which incorporates the development of their vehicle for testing. If they qualify for the competition and surpass all phases, they will compete in Jakarta, Indonesia on July 4, 2023. As we conclude this segment, I want to encourage everyone to continue valuing education, engineering, and sustainability. Let's take the lessons learned from our speakers and the initiatives presented by our students and apply them to our lives and communities. Together, we can create a sustainable and resilient future for all. Thank you for joining us today. Under the directorship of Associate Professor Divina Gracia Ronquillo, this has been Engineer Junix Kaalim, representing Education and Partnership at the Center for Innovation in Engineering Education at Batangas State University, the National Engineering University. Happy World Engineering Day.